So some people are coming in. Good morning, everybody. Welcome and thank you for joining us. So the Selkie project has been organizing a series of events focused on providing business support for companies looking to diversify into the marine energy sector. This being the very last in that series. So these events were designed to give your company the opportunity to learn more about the key themes from experts in the sector and to help in your endeavors to enter and work in these innovative and growing industries. It'll also give you the opportunity to network and meet with other companies that are working in the sector. So this session will be added to our library of other sessions that we have hosted up on the Selkie website. So you're more welcome to look back at all the other topics and sessions that we've hosted all throughout the summer. So today's session will be focused on project engineering and naval architecture for marine operations. And we're delighted to be joined today by our expert, Bob Colclough, as well as Jovi Stone from Morek Engineering. So Morek Engineering is a naval architect and marine engineering consultancy based in Falmouth. They are firmly focused on the design and deployment of marine renewable energy technologies, offering support to technology developers at all stages of the technology readiness scale. So their experience ranges from controlled confines of tank testing through to offshore deployments in some of the world's most energetic ocean environments. So in the Meet the Expert edition, the Morek team will run through some of the key learnings from the experiences and offer guidance on how they use the technical expertise to reduce risk in offshore projects. So before I hand you over to the guys at Morek, just some little meeting guidelines. If all participants could please stay on mute, that ensures that we can hear our speakers clearly and there's no feedback. If you could please include your company name and your Zoom name, that will give us a better idea of where you're calling from and help us when we're doing the Q&A a little bit later on. So if you have any questions as they come in, please pop them in the chat and we'll come to them once Bob's finished his presentation. And then if you need any assistance at any point, also please feel free to use the chat. I have my colleague Matt on hand who can hopefully assist. We have also been running an initiative as part of Marine Energy Wales and the Selkie project recently. This is the COP26 initiative, which is aiming to demonstrate the sector's capability and ambition to align with the goals of COP26. We would encourage you all to participate by looking at or using the hashtags 26 for COP26 and We Support Marine Energy on Twitter and LinkedIn. So if you look on those hashtags, you'll be able to see all the activity that we've been plugging over the last couple of months in support of the sector. So I think that's enough from me. I'm going to hand you over now to our expert today, Bob.
Hey folks, right, so thanks very much for that intro, Jay, and Matt as well. Thanks for the invite to come speak to you guys this morning. We've prepared. We didn't really know too much about the audience that we'd have here, so we've prepared some slides that sort of cover a fairly wide range of topics in different amounts of detail. So please feel free if you do have any questions just to shoot in. Now let me share my screen, make sure we're up and running. I think that one should be okay. Everything all right there? Yeah, good. Okay. Right, so yeah, thanks for the introduction, Jay. My name is Bob Colclough from Morek Engineering. I'll just run through a quick overview of what I'd like to talk about today. So first of all, an intro to our company, Morek, and the services we provide. Chose to have a brief intro into the sort of characteristics that we consider for marine operations on a energetic tidal site. Run through some typical processes for project engineering, ones that we're familiar with and do for a wide range of clients across the marine energy sector, and then finish off with a couple of example projects. So Morek, we formed in 2019, based in Falmouth, a fairly small team, but really focused on the deployment of marine energy systems and applying our background of naval architecture, marine engineering and offshore operations to contribute to the development of the sector. We also not only work in tide and wave energy, but also more and more as every day goes on, are contributing to floating wind. So since forming, we've delivered 47 projects to 23 customers, and there's just a sort of a scatter of some of the logos of some of the people that we've been working through over that time. So what do we do? Quite a lot of stuff, really. We're quite versatile in terms of the sort of challenges we tackle. We've got sort of 8 main areas up here. So marine operations, we're qualified to go offshore. Invariably, it's on behalf of customers rather than delivering scopes as principal contractors. We are sea fastening designers. Like to go into that into a little bit more detail as later on in the presentation. We do a lot of mooring design, predominantly with Orcaflex. It's obviously a very key aspect of floating wind, but we also do that for tide energy. Naval architecture, so we do a lot of work in sort of more standard naval architecture aspects, such as stability of floating bodies, so ships, but also novel structures like wave or tide energy platforms or flow structures, hydrodynamics, and modelling of marine operations. So that often involves looking at the sort of weather limits and what might curtail offshore operations. We do a wide range of project engineering services, so they tend to be quite practical in terms of the deliverables. So writing method statements in terms of how you might do something offshore and selecting the equipment, some of which I'm going to go through later on, in particular heavy lift. We do a lot of simulation work, so mainly Orcaflex, but also structural design and simulation. So making sure we can achieve best efficiency in terms of use of steel and the load regime that structures are exposed to. Third-party verification, so that's a question of providing our expertise to determine whether we think something might be advisable or not, and see if there's any areas of weakness in planned operations or deployments of all manner of things. And also scale testing, something typically we tend to be doing more a bit over the winter, probably because of the conditions in the tank are sometimes, not always, slightly warmer than those outside. But yeah, we've designed a number of models and testing campaigns to verify things at small scale. So I'd like to talk a little bit about the marine environment itself, and as this is a sort of marine renewables focused group, probably the most interesting is the tide energy environment. It's an environment that we've operated in a lot, and I have some useful insights. You might have heard some of this information before, but hopefully there'll be a few things that you might be able to pick up of interest. Sorry, wrong way. So tide energy sites, really they're quite interesting sea areas, mainly because people like to try and avoid them. So shipping and sort of your average seaman would generally try and either steer clear of or pass through at very specific times. When we're constructing tide energy systems, we need to be there quite a lot. So it's really important that we understand all the hazards and really maximize, in order to reduce the risk of what we're trying to do. Need to sort of master the conditions and really understand what's going on, so we can decide when to do things and how to do things in a safe manner. So yeah, strong from the obvious, aside from the strong currents, there's all sorts of things that you don't experience in usual sea areas. Overfalls and standing waves. You have a very confused sea. The dynamics of the vessel are different because the shortening of wave periods. And also the relationships between some of the sort of key aspects of those sites are very different to what you'd expect and what you'd be taught about when learning about tide dynamics and the sort of wider ocean areas. I've just put up some example sites. So these, we've been lucky enough to work in and visit, I'd say most of the UK, if not, and a lot of global sites. I've put broadly 3 classes of site there, and that's really, it's not really from an energy density perspective solely, but just also the sort of challenge of operating there. So I put the sort of more ferocious or challenging sites are in red. So we've got one that we're very familiar with, Magen site up in the northeast corner of Scotland. So that's within a sort of stone's throw of John O'Groats, nestled in between Stroma and the mainland there. Been up there a lot, helping the Magen project and Tide Energy developers, Sinec Atlantis. Also Strangford Lock, Northern Ireland, slightly different site because although the currents are very strong, it's very sheltered in terms of wave action, and we've still got the wind, but it's a different challenge there. The sort of medium sites I've highlighted, I think, Blue Mill Sounds in the Shetland Isles, and also Ramsey Sound on the west of Pembrokeshire. So slightly less current there, but still relatively exposed sites, and Ramsey Island can have some pretty significant wave climate running through. And then the sort of lower energy density sites, so like the Morlays site and St Catherine's Point off the south of the Isle of Wight, very southern tip of the diamond of the Isle of Wight. So what aspects of these sites are important to us when we're thinking about marine operations? Really, so as I mentioned earlier, sort of familiarization with the dynamics of the tidal cycle. And when I mean that, I mean the differences between flood and ebb, the directionality of the peak flows and how you might want to change your heading to align to them. The sort of changes that occur during slack water and how the direction rotates at that point. If there's different parts of the water column that change direction first or start to pick up speed before the others. Below the surface, I've got illustrated there a little cute little ROV, but it's thinking about working underneath the surface and the way the relationship between current speed and depth. So on the seabed, you've got the influence of the roughness of the seabed, so you've got sort of slightly slower speed there, but we've got an increase as we go up through the water column. It's really important for transitioning through the water column, particularly with things like the ROV, where you can be sort of merrily swimming away at a certain depth and think the current is doing something, and then really above it in the area that you need to go through in order to lift it back onto the ship, there could be a lot stronger currents. So we've also got quite a lot of turbulence, understanding that, and effectively the gusts of current and how that might affect different sizes of vessels. And a big vessel effectively acts a little like a filter, because it covers many areas of different flow speed in terms of the spatial distribution of current. But a small vessel might be wholly susceptible to a gust, so something to bear in mind. Also the effects of weather. So like barometric pressure can have a big influence on not only the timing, but also the overall velocity of the current in some of these locations. Also, differences between models. I mean, we're lucky to have had, well, I guess the amount of research and sort of the fundamentals of the mathematics of the tide and astronomical bodies and all the things that generate the core frequencies in the tide. We're able to predict a long way in advance, but yeah, being able to have an idea of the day-to-day, what's happening today. Is the tide 10 minutes late? Is it 15 minutes late? Why is that? And can we prepare for it? Has it made our weather window? Has it just rapidly shrunk that, and we've got to pull things out of the water straight away? Or can we understand a little bit more and be able to plan some scenarios? Also, what's it do? When is the main current happening? So typically, you'll be taught in a a sailing course, or quite a lot of mariners are taught that the slack water occurs at the top of the tide and the bottom of the tide. So slack water when the current's at it's still and changing round. But there's some graph there from the Major site and showing that really that absolutely isn't the case. The peak flow is at the highest water and at the lowest water. So that's something to be wary of. So just a tiny bit more on the dynamics of the site. Obviously, put a fair bit into talking about the tidal dynamics. So that's one thing, and it's very important in terms of station keeping and being able to maintain a position on site geographically or geospatially. But also we've got really important parameters for that influence marine operations in terms of what the wind's doing. So that can limit heavy lift and crane operations in particular. Also have an influence on the sea state. So you might have a very short period wind sea, especially when you've got wind against current, which might be of an issue for a small vessel. A larger vessel, it just has a slightly more load on it, but it's not affecting the dynamics of the ship. And then wave height. So some sites are totally sheltered from waves. In fact, the currents do work in some instances to sort of shelter or shadow sites from waves. But in particular, the Major site and some of the sites in northwest France, we have some currents that might be coming from the side. Some waves that might be coming from the side, and that's really important in terms of the way that the ship moves and how that influences marine operation. Yeah, I think that's kind of about it that we want to speak about. There's obviously a myriad of aspects, and it depends entirely on what you're doing, but that's sort of an intro into how we might consider the challenges of a tidal site. So I'll now move into some of the project engineering tasks that we have, and the idea was that might sort of just explain a little bit more about how marine ops specific some of these aspects are, and have an idea for companies that perhaps are wanting to sort of move into the sector. So the three main project engineering tasks I've picked out today are sea fastening, heavy lift, and vessel selection. So I'll introduce them and talk through some of the details of them. So sea fastening is a term as a company we're very familiar with, because invariably every time a vessel is mobilized, we need to do some work to plan and prepare not only where things are going on the deck of the ship, but how they're fastened down. So we need to try and prevent movement, damage, loss of either high value cargo items like offshore cable, renewable energy cables, or turbines, or other pieces of foundation structure, because they obviously have a high asset value in the first instance, but also to be able to react some of the loads that we might apply to things like you see there's an ROV Lars frame, so that lifts up a subsea robot essentially, and puts it over the side. So understanding the loads that occur on that, not only from the act of lifting something over the side, but also from the dynamics of the vessel is very important. So it's a relatively specialist service, and really the thing that we like to offer for our clients is to be able to design the most efficient method of sea fastening. So that's to design something that's structured, that can react to all these loads that I've talked about, but also to take as little time as possible really to instate that during mobilization or during the preparation of the vessel in port prior to the offshore works. So I've got this slide shows some of the layouts we've done. I think they're all in the past year. Yes, yeah, they are on different size of vessels. So the process really, first of all, we'll sort of gather all the input data in terms of what is it that you're trying to achieve offshore, what equipment do we need to use, and sort of bring together the specifications of all those aspects. We'll then arrange the equipment on the deck. So quite often that's specific to the structure of the vessel and where main frames and stiffeners are in the ship structure itself, because invariably we'll be designing welded features. So we'll weld directly to the vessel to keep everything in place. Sometimes the smaller items we can lash them, and it's a bit more like attaching something to the roof of your car with ratchet straps, albeit very big ones. So once we've generated that initial layout, we've got some in-house software to look at the loads. So generate the load regime, the forces that are exposed to those pieces of cargo. So there's a few I've written down sort of basic and advanced. So first of all, the basic is applying some generic conditions from classification societies, such as DNV or Lloyd's or Bureau Veritas. Or it could be a question of simulation. So we'll have a look at simulating the response of the vessel directly and generating loads from that, which is probably less prevalent in the market, but important if you're dealing with really big equipment and you have really large loads and want to really be efficient in terms of the sort of amount of steel and time it takes to get that all ready. Also operational loads. So we'll then review sort of how a designer is performing against the loads it's exposed to and report on that. So we might move things around a little bit or redesign, add more brackets, change the brackets, a number of different things. And afterwards, that's then sent off to the client and usually a warranty surveyor who acts on behalf of the client to sort of ensure the diligence of the work that's been undertaken. Okay, that's about it really for sea fastenings. I'll just quickly run through those three examples. So on the top, we've got a tide turbine install. That was actually in Japan on the Grand Canyon 2, which is a large construction vessel. The middle layout there is a dive spread. You can see over the side, you've got two diving lars. So they're used to deploy air divers for construction work or inspection and maintenance. And then lastly, the smaller vessel there, the Wessant, is that's a small ROV that's launched over the side with a skid-mounted crane, and also a grab for moving boulders. So that's to do with some cable lay operations. The next topic is heavy lift, something my colleague Jovi I say leads on in the company, but I'll talk through this, and feel free to step in, Joe, if you need to. So heavy lift, what's a heavy lift? Well, heavy lift is quite an important thing, just mainly because of the high risk involved. And critically in the UK, we've got legislation governing this. So we've got the Lola regs, or lifting operations and lifting equipment regulations of 1998. So they're essentially there to make sure that lifts are planned by competent people, and also that the equipment used has been audited and is deemed to be fit for purpose. So that's not only in the design, but that's also in the condition of it. So to make sure things aren't damaged and likely to be to not be capable of what they say on the tab. So within the company, we've got three, well, what's deemed as what's specifically termed as appointed persons for heavy lift. So that really means that you've got adequate background, training, knowledge, expertise to be able to plan a lift and execute a lift. So in terms of planning, that's doing the design of how and what you'll be using to lift, but also to generate the method statement or the step-by-step procedure which needs to be executed to carry out that lift safely. So that needs to be risk assessed and make sure that the operations concerned are all working as a practicable risk level. So there's one thing doing onshore with static cranes on terra firma. It's very much another thing for doing it offshore when we've got the dynamics of the vessel and understanding about how that might influence the lift itself. At Morek, we've got a specific sort of framework within which we work. So we've got a standing operating procedure, which defines the policy of how we carry out engineering with heavy lifts. And then we've got a set of sort of stage gates and templates of things that we need to do for specific scenarios. So we look into whether or not a lift is a generic lift and can be carried out under some sort of guidelines. Generally tends to be things that don't have anything specific that might constitute a hazard that we need to think about in more detail. So it could be things like could be something as straightforward as using a HIAB on the back of a truck to lift maybe some bags of aggregate. But then we've got the complex lift plans when we'll need to undertake some more detailed analysis, might do some simulation. We might have a look at some of the stability aspects of vessels, and generally needs some very specific skills that aren't readily available. And then after that, we've got our sort of risk assessment stages. So operational risk assessment, stage one, so that's like a desk-based. study where you think about the risks involved with the lift and classify them and work to mitigate things that are sort of outstanding concerns. We've then got the stage 2 or the HIRA, which is usually conducted in a group, and that's prior to starting an operation. So sit with the expertise of people that will be carrying out operations to review what's planned and how we're going to do it, and allow people to generate or to contribute their experience at that point. And then at the coalface, as it were, we've got the toolbox talk, which is a question of sort of standing around prior to the lift and reviewing what's in the lift plan, responsibilities and communication lines prior to executing a lift. So yeah, it's a good example of projects engineering. It's something that we run through right the way. So you'll frequently see us on board ships supervising lifts, as well as back in Falmouth designing aspects of lifts. A little bit more on the detail of a offshore lift here. So you can see these are tide turbine lifts with offshore construction vessels. So we'll look to produce a procedure which considers the geometry of the lift, of the load and the crane and where it's going. So you can see a lift from on the deck of a vessel there to a foundation on the seabed. We'll also look at the in tide, we'll look at the working windows and when we can be on site, when it's safe to be lowering things through the water column, looking at how the lifting equipment connects and disconnects, and any umbilicals that might be involved with the operation, and also the vessel selection and how the item might be sea fastened. So in this instance, we've got an offshore installation frame that the turbine's being lifted from, which it simply is lifted straight out of, the frame welded to the deck, and then we'll slew round and then lower the turbine to its target on the seabed. Yeah, that's kind of about it. It's a fairly large topic and something that we spend a lot of time doing, but just for a sort of overview, I think that's sufficient. So the last of the engineering tasks is the vessel selection. So we rarely operate, well, because we're not vessel owners, we tend to operate or advise customers on how they select vessels in terms of chartering vessels from what's called the spot market. So there'll be a range of vessels available in the North Sea, for instance, and we'll be looking at the capability of those vessels and how they're suited to the specific construction tasks at hand. Here's a sort of list of some of the things that we might be considering. So what's the conditions on site? Is it one of those red sites, one of the super energetic sites where you might be able to just come in, stand by, lower, and then come straight out again before the currents pick up? Or is it something that we need to sit? Do we need to sit in, or can we sit throughout the tidal cycle and maintain station? Do you need any observation? So do we need to have a ROV? So to specifically monitor and supervise work, and sometimes actively engage and help locate and attach or disconnect things on the subsea asset. How long is the scope? You know, do we need accommodation even? Can we work at night? Do we need to hold anything throughout the tidal cycle? So again, thinking more about the propulsion and station keeping. How far is the port from the mobilization port from the site? Do we need to think about maybe staging operations nearer the site and also including some barges, maybe for the transportation. What sort of redundancy level? So that's really thinking about dynamic positioning, which I was going to cover in a second, and crane capability. So what's the weight of the things that we're looking to lift? Do we need to lift them into air? Things are obviously don't have buoyant forces at that point, so it's important you consider that stage of the lift. Here are some, it's just a snippet of 3 vessels that cover sort of a wide range of capability, but each of which is specifically capable of maintaining station in a tidal current with its own propulsion. So it doesn't need to be moored, it doesn't need to have any tugs or further support. It can use its own propulsion system and a clever box of tricks to control the direction of the thrust the propulsion can apply to react forces that the ship's exposed to in a tidal environment. So on the left-hand side, we've got the renewable support vessel. So it's the smallest of the vessels that we really consider. It's got two 15-ton cranes or 15-ton meter cranes. It's got a DP2 system, so that relates to the redundancy of the positioning system. So if you have specific failures, it's still able to maintain position on the remaining aspects of the propulsion system. It wouldn't have an ROV typically, unless you mobilize that in port beforehand. And yeah, approximate charter rate is about £8,000 to £10,000 a day, so with a crew. Then sort of moving up in size, we've got a mid-sized offshore construction vessel, probably between around 100 and 120 meters in length, and a 250-ton crane. We'll have a work-class ROV, so that's able on the ship at all times, but able to launch and undertake inspection work or contribute to the capability for carrying out the lift. And then pretty exceptional vessel, the North Sea Giant, one that we've been fortunate enough to be on a few times. It's kind of your all singing, all dancing super vessel. Associated with that's a pretty high price tag, but it's got 2 huge offshore cranes, 2, it might even have 3. I think it's 2 work-class ROVs. Sometimes there's an additional one in the centre, and really is capable of doing pretty much anything. But huge price tag and a lot of fuel. That's actually a diesel electric vessel, so it's one of the more efficient large vessels. But yeah, just sort of illustrates the range of possibilities there. So just like to close out with just a little bit of context and really a few pictures of some of these operations. So I've just chosen 2 projects here, one of which we mentioned. We supported Samek Atlantis in their works installing a turbine at Narrow Straits in Japan earlier in the year. Unfortunately, due to a sudden change in COVID restrictions just before or just after Christmas, it wasn't possible to go out and participate on site there. But we did a lot of the preparation in terms of sea fastening design. You see there's a installation frame underneath the turbine sat in. We designed that, so that is the frame that the turbine sat in, and its transport from Scotland to Japan on a heavy cargo vessel, and then sat in on the, well, there's a barge and the deck of the main construction vessel prior to being deployed. Also, the cable spread. So that specific operation involved not only installing the turbine, but also the export cable. So we did the sea fastenings and layout for the cable spread there. Just a couple of lessons, really. So we'd not done any work in Japan, so that was a new thing to us. So understanding the way in which some aspects of the operations that we're very familiar with, but the way in which the cultural differences around how they're executed over there, which were really interesting and sometimes a little bit of a challenge. I think the main thing really was just that equipment that we would consider to be readily available here isn't so available there. So it might need to be procured from Busan or other areas of that sort of Far East region. So really, that made us need to prepare for changes. So particularly in the barges and tugs and some of the equipment that was used. And yeah, that also, that was the main thing really. And that was a really successful operation executed by the Atlantis team there. The second and sort of final example is, it's not in marine renewable energy. It's a local project by a company called Arc Marine, who we've collaborated with quite a lot recently. So we've been supporting them with helping them to deploy their reef cube structures. So the Arc Marine team of divers actually that came up with a low carbon concrete, which they use for regenerating seabed habitats and reefs. Also use it for scour protection on construction assets. And yeah, we help them with working out how to get these structures subsea. So a little bit of vessel selection, rigging design. You can see some of the rigging and the difference really in terms of the vessels that they use there. It's a very much a smaller, regionally available vessel. We produced some procedures and also supervised the work offshore. So that was one of Jovi's projects, to go and assist the guys in putting them in. Lessons. So I think really being able to go offshore with the job always helps, because you've got the background of having planned it. But in this instance, something that worked really well was considering how the cubes would be taken out at the same time as putting them in. Sounds like a fairly obvious thing to do, but it did mean that there were some changes to the arrangements and rigging. So these particular structures have a surface buoy, so that the guys can locate them easily and inspect them periodically to monitor the sea life and regeneration of the reef there. But that was also used to lower the chains on, so a totally different set of requirements for lowering. But it also means we can go back with the same vessel, pick up the buoy and pull them back up without additional rigging. So yeah, that was a good good lesson on that, and they haven't been lifted up yet, but we hope to be involved when they do. I'm not sure when that's planned actually. So I think that's it. Yep. So you've probably heard enough from me, and maybe if there's any questions or anything, we'd be happy to talk through any specific problems or challenges. If not, feel free to pop me an email, and yeah, we can talk further afterwards.
Thank you very much for that, Bob. Yeah, I'd encourage our participants to yeah, maybe turn your camera on, use the raise your hand feature if you've got any questions. We'd like to, and we'll come around to you shortly. Yeah, I'll kickstart with a couple of questions there, and then hopefully some other people can come in. So you were kind of mentioning there, Bob, about how small and large vessels are affected differently by the sort of tidal and wave environment, and particularly within the tidal industry, there's this emphasis on using smaller vessels to help bring down costs, because it's one of the sort of most sort of prohibitive elements of doing projects in an economical way. What are some of the sort of challenges and trade-offs you've seen with people sort of selecting vessels and trying to bring costs down and potentially using things that are a bit smaller and under spec'd?
Yeah, that's a really good question there, Jay, and it really depends entirely on the task at hand. So, and also this is a really important one. At what stage in the process an operations expertise are employed? So it could be that you're either produced with a 100 ton, 200 ton lift that needs to be executed, in which case you are going to go down the route of a larger vessel. But if and there's some slightly different examples in the tide sector today, people like Naval Innovation, for instance, were to consider the installation aspects at the very earliest stage. So they've got a very light turbine, it's a lower rated power, but it's quite compact, and it allows a system to be developed around that might include, say, a function for lifting it, so like a small barge that can be operated by small locally available vessels and avoid having to go onto the spot market for larger vessels. So the sort of limitations of smaller vessels, obviously they'll sort of feel the environment more. So in terms of the dynamics in a wave climate, you start to having a lot more of a dynamic situation on board in smaller wave heights, which a larger vessel will barely see. You won't even feel some of those conditions. So the weather limits will be lower. But it's a huge trade-off in terms of the cost of those assets. So if you've got a much lower cost asset, you might be able to sit around the corner and wait till the next deep window, or you might actually include that in the project finance and part of the capital investment of the project itself. Seeing a few examples of that in the more recent sort of wave of these smaller tide systems that focused on lower energy density locations. But yeah, so it's mainly, I'd say, on the weather limits, but yeah, there could be significant opportunities there. And I think the jury's out to a little bit until we can start to demonstrate those sort of operations a little bit more. But yeah, absolutely open to optioneering and assessing the cost and feasibility of more creative solutions, should we say.
Interesting. So do we have any questions coming in from our audience there? Saul?
I got a few, Jay.
Oh, if Saul had his hand up there, and then we'll pop to you afterwards, TJ.
Okay.
Thanks, Jay. Thanks, Bob, for the presentation. It's really, learned a lot. I may have spoken to you on email before, I think.
Yeah,
Jay,
yeah. Hi, Saul. How you doing?
Hi, yeah. Nice to meet you virtually. Yeah. So yeah, we've just set up the marine energy test area in Pembrokeshire, so we're quite new to all of this, but we're kind of getting there. So I got a couple of questions. Like, we've got a tidal site, which is an estuary tidal site, and I don't know if you think, I know you mentioned a lot of considerations in terms of marine ops in the tidal sites, but I don't know if there's anything unique to a estuary site, or you've worked in the.
Yeah, I mean, we have worked in a few estuary sites. I think really, so the bits that I'd sort of flag up, well, the energy density is a little lower, so the currents that you'd be exposed to are low, which mean you can be it just constrains the operation less. And it's really the sort of environment that you'd start to be thinking about moorings a lot more, and possibly even having moorings that you might put on site and leave there for a period of time. So you've got the capability of maybe some of the multi-cats in the area, and then there's Williams Shipping and Lease have got some operations out there. So you could actually leave those moorings in, and then when you want to do work, you can come and attach with usually 4 lines to each of those moorings, and you've got a sort of station keeping function. It's relatively low cost on site, and I don't know what the shipping is like there, whether or not you can get consent for leaving bits and pieces in, but yeah, there's definitely more opportunities. And some things we've seen in the past, even to put moorings onto the land, it's a bit off the wall, but Strangford Lock during the construction, there we're talking very heavy construction. It was a huge heavy lift, but the piles were a lot closer and outside of the main tidal flow. So that, again, that means that the laying of the anchors or putting those piles in was less constrained than working in the sort of the peak flow of the main channel. So yeah, you've definitely got some opportunities there. You probably have an area of slack water that you can actually move to. It's the case in Ramsey Sound near the lifeboat station, able to sort of sit there and wait out peak flow and then move onto the site fairly easily, and maybe even conduct the latter stages of a lift there, or use different assets over there, so maybe a crane on a barge or something like that, instead of having to have everything in one package in terms of large construction vessel. But yeah, sure. loads of opportunity.
No, thanks for that insight. That's really helpful. Then I had one other question, which is sort of about decommissioning, and I know you kind of touched on it at the end there, sort of like designing in decommissioning from the start. It's probably like a twofold question. One is like, do you think that's done enough in the sort of industry? And secondly, as part of our consent conditions for sort of big projects, we've got to have like an independent expert come and review the developer's decommissioning plan. And was that something that you could do as Morek?
Yeah, sure. So first part of the question, I think it's a tricky one. It's usually fairly cursory, the amount of efforts that's put to decommissioning, just because it's something that will happen in the future. It's a problem for the future. Maybe not. There's not the same amount of rigor as if you're going to actually execute the decommissioning straight away or imminently. So yeah, there's probably a little less attention gone in there, but yeah, it's really important to make sure you've got features to be able to lift things or connect to things, or have effectively a contingency plan that might not cover route A, because costs can start to escalate very quickly when using, for all marine operations, when things go wrong. So thinking about how to contingency plan, so maybe a secondary feature to lift something from the seabed, or laying pennants on pieces of equipment so that you can actually connect in a second location and lift things from there.
We've worked on decommissioning projects where the decommissioning plan was sort of the basis for our methodology, but when it came to actually doing it, it was not feasible, which made our job very
not just one, is it, as well, Joe, on that one?
Yeah.
Well, I've seen that quite a lot.
Yeah, so good to be involved from the start on those projects, isn't it? I guess so you can design in the right lift points and whatever else.
Absolutely. And second point, so that yes, that is something we do. So we call that TPV, but third-party verification, yes, we are available for that. In fact, we've done a little bit for the Nice project over the summer prior to some of the deployments there. Obviously, it's important to be impartial and independent in that instance. But yes, that is something that we can do. And as a consultancy, I'd say that's quite a common thing, because we don't own and operate vessels, but we do contribute to using them.
Great. Okay, thanks for that.
We are running out of time, folks. I just want to make sure TJ has a chance to ask his question, and then we'll look to close up the session.
Okay, great. Yeah.
Okay, thanks, Jay, and thanks, Bob. I really enjoyed that presentation. You mentioned that you use Orcaflex software quite a bit. Is there an alternate or an alternative software for Orcaflex to, we're looking to build a digital twin of a sea buoy, and we're just looking to test the market and see would there be an alternate or an alternative software to use other than Orcaflex?
Yes, there is. We use Orcaflex and have done extensively over the past sort of 10 years, I suppose, just because it is excellent in terms of the user interface and the capability and what can be achieved with it. Absolutely, there is alternatives. I think some of the ones that are more familiar with Ansys Aqua, relatively high price though, because that comes with other packages as a sort of an add-on. But also there's a few open source things. The guys at NREL in America are always pioneering open source software and tools. I think it's called MAP, or I think that's right. Yeah, it's a module for the FAST software, but is a Morek Dynamics package, and I think in Python, but I might be wrong on that. I think it's changed gradually. That definitely be worth getting in touch with those guys.
Proteus is the other one.
Yeah, nice one, Joe. Yeah, so that's is that from Halifax, isn't it, in Canada, Nova Scotia?
Yeah, I think so.
Proteus. Yeah, Jovi, you've had a bit of experience with that. Maybe me less so, but
yeah, not
pretty good.
Not as capable as Orcaflex, but depends on what you need to do, and it comes in quite a lot cheaper. So definitely an option.
Yeah.
Okay.
So
thanks.
thanks
for those.
Definitely things out there, TJ. Yeah. Happy to talk about that in more detail afterwards.
Okay, and just one last question. I loved all your shipping stories, sea fastening, heavy lifts, the North Sea Giant, the Grand Canyon. You've worked pretty much all over the UK and Northern Ireland, the Moygen site, and up by North Scotland. I've recently seen a video of a crane dropping a wind turbine into the sea. It was quite recently. I think it was within the last month.
Wind farm, which I think is that in Belgium or maybe in the Baltic Sea. Yeah.
What do you think happened?
I can't say really. We weren't involved in that, but I mean, we've seen a sort of a candid video of it, and not much else. So it could be anything from the sort of status and of the lifting equipment, maybe something to do with the crane, maybe something's not been inspected thoroughly, been used, maybe the wrong equipment's been used. I mean, it could be all manner of things. It didn't look like it was from a jack up, and it was a very still day from the videos that we've seen. So yeah, it's not really sort of dynamic loads. I think it would be something to do with the status of some of the lifting equipment there, and it really highlights the importance of being thorough in lifting, and yeah, accidents do happen. So it's very important to be meticulous in every aspect of that, and to never consider to be complacent. I think never be complacent.
You're based in Falmouth, we've a lot of activity now coming up in the Celtic Sea. Do you think the floating offshore wind is the future? Are you going to be focusing more on this industry?
Yes, wholeheartedly. I think accessing unlocking deeper waters and understanding about how we can manage the levelized cost of energy to be competitive with fixed and the more sort of well-established fixed offshore wind sectors. Yeah, really important. And for us in the Southwest and Celtic Sea region, I mean, that's not a market that we have, so we don't have access to fixed wind because of the depths and the rockier substrates on the seabed. Yeah, so anchoring and station keeping floating structures is definitely the route down here. But yes, in its infancy, I'd say, and a bit of a buzzword for the next sort of 5 to 10 years. But we've participated this year in work for the Floating Offshore Wind Centre of Excellence, looking at moorings and anchoring, and it's something that we're really fascinated in. And you can see our little anchor handler on the bottom of our slide there. That's a real focus for the next 5 to 10 years.
Sorry, last question now, last one. You mentioned tank testing. Have you your own facility in Falmouth or where?
No, our main experience is at Plymouth at the Coast facility.
Oh yeah.
Joe's not been up, but been participating in some testing at Flowwave in Edinburgh recently as well. So we're familiar with some of the best facilities in the UK, if not further beyond. But yeah, the Plymouth facility, first class. I know there's a fair few in Ireland as well. But yeah, not been to visit them.
Maybe someday. All
I
right.
hope so.
Yeah. Thanks, Bob.
Yeah, pleasure.
Thanks, Jay.
Yeah, we are pretty much out of time now. We have run over, but I have noticed that Peter's got his hand up. Are you still okay to hang on and answer one final question, Bob and Jovi?
Of course.
Yeah, you're not in a rush to get anywhere.
From Mr. Okoya.
Okay,
Absolutely.
so if we can make this one brief, then maybe, and then we'll draw the session to a close. So Peter, over to you.
All right. Good morning, guys. Good morning, Adam. I hope you can hear and see me. My question is around basically listening to the discussions around transportation from the United Kingdom all the way to Japan. And I was thinking, I know you guys don't own the product, but I was thinking what the thought behind that is. Why haven't the customer used kind of a local supply chains / fabrication yard? And I'm assuming that would cut down the cost significantly. So that's one question. The second one is the complexity of the sea fastening analysis you would have to have done, considering different sea states as you go from the United Kingdom to Japan. Is that something you can kind of just touch around a bit and talk a little bit more? Thank you.
Yeah. Hi, Nonto. Good to hear from you. Yes, absolutely. So the first instance, using a UK technology in Japan. So not really our role, because that's the remit of CIMEC Atlantis, who we both know very well. So that was really a demonstration project. So it's very important to understand the pre-commercial nature of that and effectively the sharing of technology. So yes, I totally agree. A local supply chain would be good in that instance, but really that project was all about the learning and the advances that had been undertaken by CIMEC Atlantis and the status that they got to, and the client who had very little knowledge in that area. So it's sort of that's the nature of that project. In terms of the global shipping conundrum, yes, it depends how much effort and how efficient the solution needs to be. But in that instance, we went through the use of DNV guidance to look at global shipping areas, and we looked at ship design code to think about the loading and frequency of loads likely to occur over that period of time, and also some aspects of the expectations in terms of the return period of the conditions that it would experience. So it wasn't directly simulating all of the conditions, but they're sort of an umbrella from the Classification Society, effectively, in their experience, was the way that we undertook that one.
Okay, thank you, Bob.
Okay, so yeah, thank you everybody for your questions. Thank you to Bob for the presentation, and also for Jovi for joining us as well and answering some of the questions. If any of you have any further questions or would like to get in touch with Morek about any aspect of anything that you've heard about today, Bob's email is on screen, so that's bob@morek.co.uk. So yeah, thank you to everybody that's joined us today. This has been our last of our Selkie Meet the Expert events. We'll eventually have this session online, the recording alongside all of the others. So there's a bank on our website, that's selkie-project.eu. You can look back over all of the other Meet the Expert sessions. A link's just been dropped in the chat there by my colleague. Look back at all the topics that have been covered. These are designed as a resource to help you all if you need sort of insight to help you enter and find business and work in this emerging sector of marine energy. So yeah, I encourage you all to check out the Selkie website. We're also on Twitter and LinkedIn. You can just type in Selkie Project, keep up to date on all the diverse portfolio of work that the Selkie Project is doing. So there's a lot that's being done under the umbrella of the Selkie Project that's bringing together I'm struggling with my words today, academia and industry to help advance this sector in Wales and Ireland, as well as more broadly. So that's it from me. Thank you again to everyone who's joined us, and have a good day. Cheers.
Thank you.
Thanks.
Thanks very much. That was great.
Thanks, everyone.
Cheers.
Thanks, Jay. Thanks, Bob. Brilliant.
Bye now.